Hi, today in this video I am going to explain about chapter 2 polynomials in NCERT book. So before I enter this chapter, I just want to give you a small recall about this classification of polynomials. So classification of polynomial, it is classified into two things. One is based on degree and another one is based on terms. Let's see first based on degree. Based on degree, there are four things I have given here: linear, quadratic, cubic and biquadratic. So these are all the names. It's nothing but which is related to the highest power, that equation which contains that highest power. So that relations only we have given the names of the equations. If the highest power is 1, the equation contains the highest power is 1, that equation is called as linear. If the equation contains the highest power is 2, that equation is called as quadratic. If the equation it contains the highest power 3, that equation is called as cubic. If the equation contains the highest power is 4, that equation is called as biquadratic. If it is more than 3, so simply we can call it as a polynomial. So this is what the naming of the equation based on degree we can call this. Likewise, we have next based on terms. Based on terms, that polynomial which is classified into monomial, binomial, trinomial and multinomial. So these are all the things are nothing but which is based on number of terms. An equation contains how many number of terms, that related to we can call the polynomial is monomial, binomial, trinomial or multinomial. If the equation which contains only one term, then that equation is called as monomial. If the equation contains two terms, then we can call it as binomial. If the equation contains three terms, then it is called as trinomial. If the equation contains more than three terms, that equation is called as multinomial. Right? So this is what the classification of polynomial. So now let's see in this chapter polynomial. First, 0 of a polynomial. 0 of a polynomial, it is defined that a real number k is a 0 of the polynomial p of x if and only if p of k equal to 0. Which means if you are replacing x is equal to some number k, that should satisfy the value is equal to 0. That is what the condition it is given here, p of k equal to 0. After you are solving the polynomial, you should get the answer as 0. Then we can say that k is a 0 of the polynomial. So here I have given a definition as if and only if, which means p of k equal to 0, then we can say k is a 0 of the polynomial p of x. If k is a 0 of the polynomial p of x, then p of k equal to 0. So classification of polynomial we have seen now that based on the degree we have linear, quadratic, cubic, right? So now in this video I am going to explain about the 0 of a polynomial by geometrical representation. Okay? Already I have explained in a problematic way, that I have explained in my previous videos. That link also I have given in the description. Kindly if you want, you need some clarification about that, you can go and check in that link also. And further I'll give some explanation about in detail about this linear, quadratic, what is the 0 of the polynomial, how to find out everything. I will give you in my next videos. Okay, so and in this video I'm just going to explain about how to find the 0 of polynomial by geometrical representation for linear, quadratic and cubic. Okay, so the next exercise, I think you have relationship between zeros and coefficients. So that next video I'm going to do that. In that video I will explain in problematic way how to find out the 0 of the polynomial elaborately. So now let's see how we have to find out this 0 of the polynomial in geometry. in this Cartesian plane, right? So here, look at this chart I have given here about linear, quadratic and cubic, right? Linear in the sense nothing but the highest degree is 1. That's why I have written that polynomial p of x is equal to ax plus b. So ax plus b, that variable x, it contains the highest power is 1, right? So here I have given it's a straight line, which means if you have drawn a diagram in a coordinate plane, you should get a diagram like a straight line for linear equation, right? For linear equation, we have only one 0. That is what I have mentioned here, 0 of polynomial inside the bracket minus b by a comma 0. How to get this? See, look at here, ax plus b equals 0. When we are transposing b next side, it will plus will become minus. So ax is equal to minus b, and next you have to transpose a next side, and this is along with x, it is in the form of product, so it will change into division. So x is equal to minus b by a. So that is the 0 of the polynomial here. So when we are substituting the value x is equal to minus b by a in the given polynomial, you should get the answer as 0, okay, for y. So that is what in that ordered pair I have written minus b by a comma 0. The first one which is representing your x ordinate, and the 0 which is representing your y ordinate. This part where, let's see that detailed part in that next. I will explain about its diagram. Through diagram, I will explain this next. Quadratic formula, that equation form I have given here, the general form p of x is equal to ax square plus bx plus c. For that quadratic equation, if you have drawn on graph, you can get the diagram like parabola. It may be upward or downward, which is regarding to your a, which is greater than 0, you may get that upward, or a less than 0, you may get that in downward. So these two kinds of representation only you can get from your quadratic equation, right? And how many zeros of polynomials are there in quadratic equation? A polynomial of degree 2 has at most 2 zeros. At most 2 zeros in the sense it may be 1 0, or it may be 2 distinct zeros, or it may be no 0. So at most 2 zeros, which is less than or is equal to 2. It may be 1 or it may be 0. No zeros. Okay. So that is what the meaning of at most 2 zeros. That also, let's see in graph I will explain elaborately how we are getting 2 0 and 1 0 and no 0, everything. Then cubic polynomial, that is the general form ax cube plus bx square plus cx plus d. So for this cubic polynomial of degree 3, it has at most 3 zeros. Similarly, what I have said for 2 zeros, right? A quadratic, the same thing for cubic, we have at most 3 zeros. So let's see the detailed explanation part. Through the graph I will explain. See, look at here, this is my first example of graphical representation. Look at the diagram here. This is the graph for a linear equation, right? So what is the equation? It is given here, y is equal to 2x plus 3. So the higher order is 1. So that is the equation is called as linear equation, and already I told you that for linear equation we can get the graph like straight line, right? Okay, so now how to find out 0 of the polynomial by the graphical way, which is very simple. You have to remember only one thing, that is where the graph intersecting x-axis, that point is the 0 of the polynomial. So already I told you that for linear equation we have only 1 0 of polynomial, right? Now look at the diagram where the straight line which is intersecting on x-axis, it's clearly shown. See, look at here, this point, right? So that point is nothing but it is minus 3 by 2. So what is the 0 of the polynomial for this linear equation, which is nothing but minus 3 by 2. Sorry. Minus 3 by 2 is the 0 of the polynomial, right? Okay. So this is a very simple to find out by graphical way. So we have to look at the graph, and the graph where it is intersecting x-axis, that points only we are going to say it is 0 of the polynomial. So for linear equation we have only one 0 of polynomial, and this is an example of a linear equation. Now let's see for quadratic equation. See, look at this diagram here. This is the graph for quadratic equation. See, look at that equation. It is given here, y is equal to x square minus 3x minus 4, which is nothing but our quadratic equation. And already I told you that for quadratic equation, the graph, it look like upward parabola or downward parabola, right? So here I have given example of upward parabola, and already I told you that for quadratic equation, a polynomial of degree 2 has at most two zeros. At most two zeros in the sense, I told you for three cases there is no 0 and 1 0 and two zeros, right? So here actually this is an example. Let's see next that all three cases. And this example, how many zeros are there? Look at the graph, that x-axis where the graph it is intersecting, here and here. It is clearly shown here. So that point is nothing but it is minus 1. One point is minus 1, and this side the point is 4. So these 2 points are the zeros of the, or the 0. Okay. 0 of the polynomial. Okay. So this is what we have to notice in the graph, where the graph is intersecting on x-axis. It's very simple. Now let's see the three cases for no 0 and 1 0 and for 2 0. So here let's see that first two cases. Look at the diagram here. The first case, it is upward and downward, both parabolas I have given, right? This is for downward and this is for upward parabola, and both the parabolas it is given only for intersecting that x-axis at two distinct points. See, here 1 point and here 1 point. Similarly here 1 point and here 1 point, right? For both zeros it is intersecting this quadratic polynomial at two distinct points. This is one case, which means the highest one, 2 zeros, right? The next case it's showing that for x-axis it is intersecting the graph at exactly 1 point. That is very, very important, because the points they are coincide, which that is what the points are coincide. So we are getting only 1 0 of the polynomial here. So that is nothing but here. This is the only 1 point it is intersecting. So here how many zeros? It is 2 zeros, and here how many zeros? It is 1 0. That is what important to look at the diagram. So this is the first case, and this is your second case, and the third case for your quadratic polynomial. These two diagram, look at the diagram, both the one I gave it now. So here this is for downward, okay, downward parabolas I have given here. It's only 1 point. So if you have drawn a upward parabola also, like if you have drawn like this, any upward parabola, that also there is no point of intersection with the graph, right? It is drawn below the x-axis or above the x-axis. It is not intersecting. So this one we cannot say that 0 of the polynomial. So there is no zeros if the polynomial, that graph is not intersecting with x-axis. So these are all the three cases. These are all the no 0 of polynomial. Okay. So this is what you have to remember, whether it is upward or downward parabola, it is not intersecting with x-axis. There is no 0 of the polynomial. So we have seen in quadratic equation what are all the three cases about this at most 2 zeros. No 0, 1 0 and 2 0. Okay. And now let's see for cubic polynomial. Cubic polynomial, the diagram it's look like, okay. So it depends the equation what it is given, that according to that you can get the diagram like this. So a polynomial of degree 3, it has almost at most 3 zeros. Okay, it is at most 3. Okay, now you just look at the first diagram and tell me where the diagram is intersecting at x-axis. This is the first point, here, here and here. So totally how many zeros we are getting? three zeros of polynomial. Okay, and look at this diagram here, and intersecting with origin, and here 1, 0, right? So there are two point of intersection on x-axis. So for the second diagram we have two zeros of polynomial, right? So these two things we have to remember for a cubic polynomial. Yes, so likewise we can get the diagram like at most 3 no 0 1 0 2 0, and at most 3 zeros we can get the zeros of polynomial for cubic equation, right? And let's see few examples. I just show you. You just say the answer, how many polynomials are there. Okay, if you are giving a correct answer, you got it. What is the meaning of zero of polynomial and how to find out the zero of polynomial using geometrical representation. Let's see, can you able to find out or not? Tell me the answer for the first diagram. How many zeros of polynomials are there in your first diagram? Look at the graph and just tell me the answer. Yes, you got it? Yeah. Here only 1 point, and in this graph here, don't bother about y-axis. We have to concentrate only the graph intersecting on x-axis. So where it is only 1 point, it is intersecting. So zeros of polynomial is 1 0. 1 0 of polynomial. What about this diagram? Also it is intersecting. So here also it is 1 0 of polynomial, right? And let's see the second example now. Okay. See, look at this diagram and tell me how many zeros of polynomial it contains. Just look at the diagram carefully, and where the graph is intersecting on x-axis, here and here. So what is the answer? 2 zeros of polynomial. And here it is intersecting at only 1 point. So here it is 2 zeros of polynomial, and for this one it is 1 0 of polynomial. Okay, let's see one more, the last one I'll give you. Yes, this one. Tell me how many zeros of polynomial. Just look at where it is intersecting. 1 2 3. So it is here for 3 zeros. Okay, and here 1 2 3 4. Here it is 4 zeros, so it may be a biquadratic equation for that graph of a biquadratic equation. So 4 zeros we have. Okay, so this is the way to find out zeros of polynomial in a graphical way. Okay children, I hope you all understood how do you find out the zeros of polynomial for the given graph. So just go through that your first exercise in chapter 2. We have some problems related to that. Find out the zeros of polynomial. If you can able to see the correct answer, you got it. Okay.